Welcome to Code Report. I'm your host, Connor Hoekstra. Last week we had 4 contests and 1 contest that started. On Tuesday we had from Code Forces round 525. On Friday we had the start of the December long challenge from Code Chef. Make sure to compete in that one because I'll be doing a video dump for the Division 2 problems. On Saturday morning we had from Hacker Earth the December Easy contest. On Saturday evening we had from LeetCode the weekly LeetCode contest number 114. And on Sunday we had from topcoder the SRM 743 contest. Taking a look at the top 10 leaderboards, here it is for the topcoder SRM 743 contest. A ton of familiar names in the Division 1 contest. In first place was the Canadian KSun48. In second was Stonefang. In third was QWERTY787788. In fourth was LHIC. In fifth is RNG58. And in ninth and 10th were Tourist and Piotr, respectively. Taking a look at the top 10 leaderboards for the other 3 contests, the most familiar names from these were in the number 1 spot for the Hacker Earth December Easy contest. Bohdan Prishenko placed first, otherwise known as I Love Tanya Romanov. And in the LeetCode contest, we had John Cram in first, Yui in second, and Natsugiri in ninth. In today's video, we'll be covering problem 1 from the topcoder SRM 743 contest entitled Playing with Planks. The problem states you are given a plank of length L. You want to cut the plank into exactly P pieces such that the length of each piece is a positive integer and all the lengths are distinct. If it is possible to cut the plank in the described way, return possible, otherwise return impossible. And the constraints for this problem are going to be L, the length of our plank, will be between 1 and 1,000,000, and P, the number of pieces we need to cut it into, is going to be between 1 and 1,000. So let's take a look at a couple examples. This is a pretty simple problem, so it'll be pretty fast. So here are 2 examples. We have for the first one the input 9 and 3. So 9 is the length of our plank and 3 is the number of pieces. And the output for this is going to be possible because we can come up with a number of solutions, but one of them would be the following. So we've got one piece of length 1, another length 2, and another of length 6. And if you add those up, you get 9, and all of these have distinct lengths. So none of them are the same. And for our second example, we have a plank of length 10 and 5 pieces that we want to cut it up into. And this is going to be impossible. And you can sort of see that if we approach this by first cutting length 1 from our plank, and then length 2, length 3, length 4, continue to do this. This is sort of what's going to motivate our algorithm. Once we hit a plank of length 4, we already have exhausted our plank length of 10. So we're not able to cut a 5th piece with a length that hasn't already existed before. So we have to return impossible. So that's going to motivate our algorithm and basically going to be the way that we solve this. There's going to be 2 different ways. The first way is we are going to sort of brute force subtract from our plank length the distinct sub-plank lengths. So we'll start with a plank length of 1, and then we'll have a for loop for the number of pieces that we need to cut out of our plank length, and each time we will subtract that length, so starting at 1 from our plank length L, and then we will increment the 1 to 2, and then subtract that from L, and continue to do so until our sub-plank length is equal to P, at which point we can just check, is the length our current length left in our plank positive or greater than or equal to 0. And as long as this is the case, we know that we were able to cut P pieces with distinct lengths. That'll be the first way, but there's actually a shortcut that you can use to do this without looping, and that's by making use of the formula that is the sum of an increasing series from 1 to n, where the increasing amount or the incremental amount is 1. And that's the following formula. So usually you see instead of p and n, but here we're using p because that's what we want to use. P times p plus 1 divided by 2 is equal to the sum of this series here. So if p was 4 and we added all this up, we are going to get 1 plus 2 plus 3 plus 4 is equal to 10. And if we use p equal to 4 here, 4 times 5 is 20 divided by 2, which is also 10. So we can solve this problem in constant time by making use of this formula and basically just plugging p in here and then checking, is the result of this equation less than or equal to L? If so, it's possible, else it's not possible. So hopefully this makes sense. It's a pretty easy problem. Let's take a look at our code. So here is the first of our C++ solutions. It's a two-liner. As you can see, we have a function, can it be done? It takes two parameters, two integers, L, the length of our plank, and P, the number of pieces it needs to be cut up into, and it returns a string, either possible or impossible. And on our first line, we have a for loop from I equal to 1. That's the starting length of our sub-plank length that we're going to cut out of our plank L, and we're going to increment up until this amount is equal to P, and each time we just subtract from L this value. And after we finish this for loop, as mentioned before, if the length left in our plank is greater than or equal to 0, it means we were able to do this, so we return possible, else return impossible. The second C++ solution is a one-liner, and it makes use of the formula that we talked about. So if P times P plus 1 divided by 2 is less than or equal to L, return possible, else return impossible. And we'll show one other solution, which is the Python solution, very similar, not showing the Java because basically it's identical to the C++ solution. Java has all of these string literals, ternary operators. The only thing that's slightly different is that this is an S, and the integer, I think this part is exactly the same too, so no reason in showing it. But the Python solution is slightly different. It doesn't have the ternary operator, but it does have this syntax where we can return possible if and then P times P plus 1 divided by 2 less than or equal to L, else return impossible. So this is sort of Python's equivalent of the ternary operator, which exists in other languages. And the last thing to talk about is the time complexity for this problem. For this solution, it's going to be constant, but for the solution where we're looping through the number of pieces, it's going to be linear in P. Taking a look at the contests happening next week, it's a pretty light week. We only have 3 contests. On Monday, we have from Code Forces round 526 for Division 1 and 2. On Saturday, we have from Hacker Earth the Hour Storm number 6 contest, and from LeetCode the weekly LeetCode contest number 115. And also throughout the week, we will have the December Long Challenge contest. As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.